Hello, this is a quick video overview of the functions and triggers topic before the practical on Monday. Hopefully you've all had time to read this, so me reading it won't be news to you. Two sections, first section functions, second section triggers. What we're talking about here are ways to enhance our relational database models through adding code to the models that we're building. So we know that we can rely upon our database management system to enforce integrity in terms of key constraints, for example, and uniqueness constraints, but there might be other things that we want to do that the database can't do, like, for example, mandatory relationships. That's where these triggers come in. With SQL, vanilla, unmodified SQL, as we know, you can create tables, you can insert things, you can update, you can delete things, you can drop tables, which gets rid of them completely, and you can select things from tables. SQL has a very small set of commands. When we talk about modification, the things that we can do are insert, update, delete. So if we've got a table, we're going to insert things into the table, we might update the contents of the table, or we might delete things from the table. What we're not doing is anything else. So what functions and triggers let you do is attach a trigger to one of these actions, which then, instead of carrying out the action straight away, does something else. So you might attach a trigger to insert, connecting to a function that says every time we insert something into this table, take a copy and put it somewhere else. You might have a function attached to the update that says every time we update something in this table, what we do is we check that the total still makes sense. Or we might have something associated with deletion. So you might say every time we delete a tutor, what we do is we double check that there aren't any students associated with that tutor. So we might have a function that goes and checks that logic for us. So what we're doing is we're associating some kind of software logic with an SQL action. Within Postgres, we write our functions in pgsql, which is a procedural language within Postgres. And this lets you use all of SQL, so it's got all of SQL within it, but it lets you extend it with your own functions. You can put other languages inside Postgres, but pgsql is the standard one that's installed in all installations. Things you use it for, you can use it to enforce mandatory referential integrity constraints, so the whole one-to-one mandatory both ends. Every tutor must have exactly one student, every student must have exactly one tutor. That kind of thing can't be enforced within SQL without doing something outside of the referential model, and what functions and triggers can do is they can check that for you. You can also use it for other stuff, so you can group queries, you can make sure that when one table changes, other tables change. You can use it to check things, you can use it to enforce integrity, you can use it to do business logic. You can also use it as a kind of auditing thing, so you can have it every time we delete something from one table, it gets inserted into another table, for example. And then you know that you've always got a copy. Our functions within pgsql have got three main sections. They start with a declare, and then you have variables and so on. Then you have everything goes between begin and end. If you've got exception handling, that goes between exception and end. So declare some variables, say we're going to begin, do the program logic, say exception, describe what you're going to do if something goes wrong, and then end. Obviously finishing with a semicolon, because everything finishes with a semicolon. Practicalities. You need to prefix with what the function returns and also the language the function is in, and the body itself should be bracketed in $2 characters. The dollar characters can have a keyword between them just to make it easier to understand. That's usually good practice. And we always use names to identify what we're doing, and the reason we do that is because if you've created a function, if you don't name it, you aren't going to be able to call it, and you ain't going to be able to delete it. And both of those are things you probably want to do eventually. inside your functions. There's certain specific words that we can use that have a special meaning inside your pgsql. These are new and old. If you're doing a function which is called before an insert or an update event, then the variable new will hold whatever the database is about to insert or update. So you can do things with data before it hits your tables. If you're going to do something after a delete or an update, then the variable old holds the things that have just been deleted or just been updated. So that's a record of what used to be in the table. The new holds what's going to be in the table after the query's run. The old holds what was in the table before the query was run. So there's a null value returned if you're looking at new for a delete event, or if you're looking at old for an insert event. What I'm going to do now is I'm going to add a function to a database. I have a database window here. So in this database, I've got a lecturer table, and in that lecturer table, I've got some lecturers. We can describe the table, DT lecturer. So you can see there's a table called lecturer. And it's got a primary key, and it's got name and address and so on. And what we're going to do is insert into that table a function, or attach to that table a function. And the way I'm going to do this is by typing it in. Type it in. I'm just getting it up to look at. So we're going to have a function called sendCard. And what we're going to do is create or replace function sendCard, and we're going to make a sendCard function. And what that's going to do is it's going to send, add to the leaving card table anyone who we delete from the lecturer table. So everyone who gets deleted from the lecturer table gets a leaving card. This function is going to return a trigger as $cards. Then I'm going to have a begin, and then insert into leaving card name, address, values, o.name, o.address, semicolon, return old, semicolon, and $cards language pgsql, semicolon. Okay, and that's entered the function into our database. And we've got, as I mentioned before, I've got a lecturer table. Have I got a leaving cards table? I've got a leaving card table, which has just got name and address. So that's the function in. That's pretty much what I was going to type. I think that's pretty much what I typed. I called it leaving card instead of card, but that's because I called the table that. And I did create or replace function because that's better. If you want to update a function, you can just use replace. If you use create or replace, it will create it if it doesn't exist and replace it if it does exist. If you want to drop a function completely, you can use drop function and then the function name, and the function will be deleted from your database. So now that's a function, that's how you create a function, and that's how you access stuff from old and new. Now I'm going to look at triggers. So triggers are called triggers because a trigger does what a trigger on a gun does. If you pull the trigger, the bullet is shot. If you update data or do something that a trigger is attached to, it will trigger the running of a stored procedure. So the syntax of a trigger: create trigger, trigger name, either before, after, or instead of a particular event name on a particular table name, and then you have the trigger logic. Usually, trigger logic is a function call, and usually it's something you want to do before or after something. If you do set up triggers that run something instead of something else, that's kind of high risk. So if you have a trigger that instead of inserting on a table does something different, your database is going to behave very unusually. So normally what you'd do is you'd use these to do something like as well as a particular command. The before keyword will mean that you triggered it on a row before any constraints are checked and before the insert, the update or the delete is attempted. If you do it after, it's after the operation is completed, and again the insert, the update or delete will have happened by the time you run it after. And if you do it instead of, it replaces the event completely. For before or instead of, you can change what goes into your database. So you can completely change the way the data behaves based upon what happens, because you can write a function to do pretty much anything data-wise that you want. So here's the trigger example we're going to use. We're going to create a trigger called leaving card, and after delete on lecturer, we're going to send each row to the send card procedure. So that will call the procedure that we have just defined. So let me get my database up. And we'll stick that in. Create trigger leaving card after delete on lecturer for each row execute procedure send card semicolon. And that is our trigger, create trigger leaving card after delete on lecturer for each row execute procedure send card. Got it. Enter, create trigger. So our trigger's been created, right? So if we do select star from leaving card, got nothing in there. And let's say we do delete from lecturer where email equals hmd1@outlook.ac.uk. It's deleted one. So now if we do select star from lecturer, we've only got 3 lecturers there. And if we do select star from leaving card, you've got the name and address of the person that we've deleted. So what we've done is we've written a function that says when we delete someone from the lecturer table, we copy their name and address to the leaving card table, and then we've attached that to a trigger which makes it run whenever somebody is deleted from the lecturer table. So we could try that, run it again, delete it from the lecturer table where it is another lecturer of renown. And now if we do select star from leaving card, there's a couple of lecturers in there, and select star from lecturer, the ones that we've deleted are gone. So hopefully you can see that's useful, right? You're able to keep a record of what's happened. If you want to remove a trigger completely, you can use drop trigger, and that will get rid of the trigger from the database completely. If you don't name the triggers, you can't get rid of them. That's one of the reasons we have to be really careful about naming the triggers in our databases. And this is part of our arsenal for integrity checking in general. So we've looked at integrity over the last 5 weeks. We've talked about how you set your database up so it's got integrity to begin with. We've talked about how we manage to get the data into normal forms, which gives it integrity. That means it's going to have uniqueness, it's going to have referential integrity, it's going to have primary keys, it's going to have foreign keys, it's going to have unique, not going to allow nulls where they're not allowed to be null. And now we know that you can use functions and triggers and stored procedures to enforce integrity actually within the database. And when that fails and you can't do it with functions and triggers, you might want to do it in application code, so you might want to do it in Python. But honestly, you should try and get the database to do all the heavy lifting. Make sure the procedures work at the database end, because it's a more efficient way of managing things. Remember what we were talking about with ACID in the lectures on Monday? We know that atomicity, consistency, isolation and durability are all very important. What functions and triggers do is they help us ensure consistency, so you can enforce your referential integrity within the database system. And that's the end of this mini lecture on functions and triggers. Practical will be on functions and triggers.